So each time we stand up and we look, we see an eye level. Your eye level. That's where your eye sees a straight line. That's your eye level. So on each end of the eye level, where you can no longer see, is your vanishing point. Images vanish there. Can no longer see. So that's your observable space. However, within that, so let's create the eye level before we get any further. So that's on the paper and no longer in abstract equator form. So here's the eye level. Now you have the observable space. Here's VP1. I'm sorry, I'll write eye level here so it's not as confusing. And VP2. Now VP, vanishing point, 1 and 2. Now, where is your observable space? Your observable space is all here. But to find the observable space, you have to find the center line, find the center of this, and from here, using the radius as this, locate it. So I'll show it to you. It's better done than said. So how do you quickly find the center? You use the compass. You place the arrow here. You make a large enough space here.
I see.
But I'm sorry.
Wherever they intersect.
Yeah, where they intersect. So I'll just imagine that I am a pencil graffitiist. So it's gonna be probably about here. So here's your center. Here's your center. Here's your center. Now you have a line going down here. Now I would use a this here, so you get a straight line because it's perpendicular. So just use this, get your 2 points. Then here you go. So somewhere here will be a perfect point of station point, but we'll get to station points later. Right now, I'll tell you why we're doing this. We're finding the center. We've made our eye level. We have located the center. From using the radius of half of this distance, we'll now show all the visible space that's available to you when you as a person look at. So, start here. This is going to be this size. And sits up to here. Then you just do this. Oh, must have not found the center exactly. Well, let's just shift everything.
Classic cheat.
Yeah, just hit, and whatever you hit is the target. So, just for the sake of time, I'm going quickly, so I'm making some errors. But here's VP1, here's VP2, here's the eye level. Here's the center that you found by making those 2 compass arcs, and where they cross, you have drawn the line through. So here is one of the station points. Now let's go over station points, and let's go over your viewpoint, your 60-degree angle. So station points. How many station points can there be, and what is a station point? A station point is where you stand. It's your position as you look out at the eye level. This is your map. You're looking out at an eye level. You have a vanishing point. The greatest distance you can see arcs around like this. So it expands this way. And if you happen to be here, you have a more limited visual spectrum. So where could station points be, and how many station points can there be?
Infinite.
Exactly. They could be all over here. They could be here. This will give you the best one because it will give you the right angle. The right angle will give you the best, the most area to look to use. It'll give you the most area. And so I would advise always use the 90-degree station point because it will allow you to place the most objects into the area that's available to you.
So station point is the place where you stand on.
Mm-hmm. So here's another station point, an example. So here's another station point. It could be here. Could be here. That's a scary one.
So just within the purple outlines, right?
Yes, yes.
Okay.
And this is a bad one because it's almost going out of the vision.
Yeah, it's like the cheap seats in the baseball stadium.
Yeah, exactly. So this I would say is the best. Right here, this triangle. But now we'll go to the next thing, which is this one. So we've decided that this is the best formation. The 90-degree angle is the best. We have proof for it because all these sharp angles are horrible. So we have proof that this is the best one. But here's the problem. Yes, you can see all this, but there are areas that you'll have distortion. So where you're limited once again, you're limited to 60 degrees where there's least distortion, where your peripherals don't play tricks on you, where you actually see clear. And that's about 60 degrees, about this much. So about this much of this 90 degree is how much you actually see very well. And this is where you would like to place your objects when you make an environment. Because otherwise you'll have a fisheye view. You have a weird distorted view. Not necessarily fisheye, but you will have a very distorted view. So here's where we want to place our objects. And it's called the cone of vision. It's called the cone of vision, where your vision is the clearest. Vision of objects is not distorted.
I see.
Did any teacher ever teach you this? No?
I watch it online though.
Okay. Yeah, it's good.
60% of the vanishing point between these 60%.
Yeah, the vanishing points is what you see
Yeah.
clearly. Yeah. Okay. I was wondering if this, other than clap, there was any other source that.
That's
No,
why
I
I was.
never heard
That's
of
why
it
I was
before.
like always wondering, like, is there anyone who can actually teach us like this?
Actually, this book I've been reading.
Oh yeah, I lost the title of the book.
The how to render or
No,
how
no,
to draw.
no, perspective handbook.
Perspective.
That's another one clap
Recommend.
yeah.
So.
I just basically store all his book lists and just read everything.
So.
Perspective.
This is perspective setup. Now we'll reintroduce Delilah's, and for most of you, introduce her. So who is Delilah? Delilah is a very anorexic soul that inhabits the land of perspective. She's very sad. She's basically just a stick that tells you how to make every object that you need to make in an environment.
Cool. Thanks, Delilah.
Yeah, we love her. We love her. She's a little confused as they go. Like she'll just aimlessly wanders the land of perspective beyond.
Perspective beyond.
I can't think of a name right now. Okay. The Perspectiveberg. That's the capital. Sorry guys, this is gonna be a little messy. I'm going fast. Okay. It's squeaky. I wish you guys had clap. The clap experience is so great. You guys
Yeah, I was pretty sad when that happened. I was like, oh man.
Oh, look at this.
Oh.
Does he teach graduate courses?
He
Right.
teaches. Yes.
So if I got a master's, I could take him.
We
If I
don't
got
have a
in
master's.
there's
We
no
only have a
master's.
bachelor's. You have to be in the program to get to him again. Yeah.
Why does that have to be so hard?
But you can do what he does.
What?
He stands next to
No,
open.
no, you can't do that because then they'll notice us.
What?
Yeah, he
when
knows.
they prop the doors open when they have videos playing because it gets really hot, and so I just sit outside the door and take notes.
Yep.
Oh.
Okay. Okay, let's go
They-
to Delilah.
They don't. I don't think they want me to be there.
No, they don't.
I don't know. Some people told me that some students already took this class. They actually could go in there and they just do their own thing.
Yes. If
Yeah,
you
can
have
I
our-
just go? Can I just go into class and sit in the back?
No,
No.
Why? Oh my gosh.
because then you're getting.
That's what the dean said no to. Trust me, if Clap allowed that, there would be no this class at all. You guys could just go to his
Okay.
class.
Yeah.
Yeah.
Okay. So
I wish.
I
so
wish.
now I will tell you about Delilah, and I will tell you how to move her in with two different conditions. The first condition. Well, first let's introduce Delilah. So 60 degrees. So here's a quick way to get to 60 degrees. You just already know innately. This is your station point. It's going to be at 90 degrees. Now you just need to mark your 60 degrees. So say 30 here, 30 here. That would give you 60. Sorry, did I do this? No,
60 degree percent.
60.
I know, 60 degree, but it's just basically 60% of this area.
Really?
Yes.
It is 60%.
Yeah.
Oh, I didn't know that.
Yeah.
Yeah, I don't think of that. 60% of which area?
Is it?
Because it's 180, so it's actually 1/3. So it would be like 33%.
Yeah, I thought 40%.
Yeah. Because degrees for hemisphere, the degree is for semicircle, the number of degrees you have here is 180.
We can
So-
try. We can try to measure.
I just got a point to prove.
Okay, so 10 half.
It's but yeah, but what if you had this station point like right here, and then
Yeah, it would change depending
It
on
would
the
change.
distance from the eye level.
yeah.
Okay.
Yeah.
okay.
Okay. Now let's imagine. Well, here we have 60 degrees. Let's just put the Delilah inside this kind of setup. So say let's make Delilah an inch long. So everyone, welcome Delilah to the world.
Hi, Delilah.
Here's Delilah.
That's
Yeah,
what
she's so
she's
sad
graphic.
looking. Okay, what if you want to move the Delilah in perspective, maintaining her size? So you want to make another inch-long girl, but right here. Any ideas on how you would do that? Not from you or you.
Yeah.
Don't worry, for God's sake, I need a refresher.
You want to make another Delilah where?
Right here.
That's fine, but you have to draw those railroad track lines to the vanishing points to see the sides. You know what I mean? You have to go like this.
Do I have to go? Oh, do you think I have to go to both of them together?
It should be the same.
Well,
if you
you're
just
drawing
push it
her
along.
right there, so just go from here to here and here to here. You know what I mean? Go like this.
Oh, but she's standing right here. This is where she begins.
Wait, what is Delilah?
Delilah is a line, just a regular line. That's what Delilah is. And what we're doing is we're moving the line around. So your guess was make railroad tracks, and that's very good. That's a good guess. We're making railroad tracks through the
Oh.
bottoms.
It's you have to relate I'm just saying you have to relate these two. They
Mhm.
have to be on the same track.
Yeah, they do, but they don't have to go to the VPs.
Right, I
Yeah.
see. Yeah. It's
So-
with that's
So
right.
what
yeah.
you do is you go through them,
Okay.
and now welcome the new reference point.
Okay.
Now the reference point, not to be confused with the VP, any point here could be a reference point
Mhm.
because lines can
Mhm.
come from anywhere.
Mhm.
So this whole
Mhm.
line is essentially a reference line. It's
Okay.
free.
Yes.
Wherever you're not limited to these railroad tracks.
Mhm. Okay.
Now you're drawing, remember Delilah is not lying on the ground, she's standing on the ground. And so if I was like to draw a shadow, this could be like her shadow. She's standing on the ground. And what we're trying to do is we're trying to make the same size. So we just drag the top along to the reference point, and now we draw,
Okay.
and here you go. This is an inch long Delilah, this
Yes.
in this distance.
Yes. Okay.
So these are not railroad tracks.
Okay.
What they are, they're fences in perspective.
Okay.
These are fences in perspective.
Okay.
Fences of Delilahs. And then you can have a whole army of Delilahs.
Okay.
All standing one behind the next.
Okay.
So the reference point is the one like is that what do you call that? Eye level? Is like
The reference points are on the eye level.
okay, just trying to make sure.
Yeah.
Oh, I forgot I was recording. I wasn't even holding it. It's okay.
So now, like, the reference point is on the vanishing line.
Eye level. Reference points.
Horizon.
Yeah, horizon. Horizon. Oh, yeah, you can call it horizon or eye level. By the way, if you guys are confused, eye level, horizon, same thing. Though, there's just quickly, don't let it get to your head too much. But there was this point in Clap's class when someone said horizon line, eye level, and he said yes, horizon line. But what if it's foggy? So you don't see the horizon, but you still have an eye level.
Yeah. Or if there's anything between you and the horizon.
Yeah. Quick level he just discovered on how to see eye level. If you have a water bottle, you're wondering like, where is my eye level? It's something Clap just told us very recently. When the water is a line.
And you don't see ellipse.
Yeah. When you don't see ellipses, you have your eye level. So if you're
Okay.
drawing, you're like, where is my eye level? That's your eye level.
Okay.
Just a tip that he actually shared with us very recently. So this is how you would move Delilah in a distance. So say I made a 2-inch Delilah right here. And now I want a Delilah based right here. Someone tell me what I would do this time.
It's the
Do
same
the
thing.
same
From the
thing.
bottom of this one through there
Yeah.
to the
So
horizon line.
here there would be a reference point.
And then to the top.
Oh, by the way, why we use the eye level? Why? Why eye level? Because on the eye level, everything vanishes to a point. Everything is a point on the eye level. The eye level is a line of points. One of my teachers said that a line is a point that went on a jog. Well, this jogging racetrack is right here. That's the eye level. So,
Or it's just a really big army of dots. They're so
Yes.
far away you can't tell the difference anymore.
yeah, there's so many, they're an infinite amount. So, feel free to either take pictures of this, whatever you guys need to do to later after I finish this lecture. So next will be moving Delilah. And I will quickly just do this right on here. So, well, it's kind of messy. I'll do it here. Should I have it this? Oh, actually, I'll do it right here. Again. Yeah, I'll explain why this is how it looks. So, moving Delilah at same distance. So, moving Delilah at the same distance. This is, remember, changing the distance constantly. This will keep Delilah grounded at the same distance. So imagine this is within the 60 degree, forget about VPs, this is in the 60 degree realm. So if she is going to be moving at the same distance, she's not going to change in size. So what visually you're conveying to people, if you have a line that's not changing, that's the same and they know it's the same thing and it's not changing, you're telling them that they're seeing it at the same distance. It's the same line seen at the same distance. So what if you move Delilah to the left or the right? So here I moved her to the right and here I moved her to the left. So you would take your dividers. Now I don't want separate dividers, I just use my compass for everything. Less things to carry in my backpack. So you just have here, you take these measurements, and then you just move right over here on the same line. Or you move right over here. Make a perpendicular. And here's your Delilah. Here's your new Delilah. And she's the same size as the green original. And here we're just shifting her left to right. Now what if you want to levitate Delilah? Shift her up and down. That's all it is. Levitate her, shift her up. Bury Delilah, shift her down. Now fall on Delilah. Now this is where it's going to get a little bit more confusing. Because when she falls, you're not going to see this. Always. You'll see it sometimes if she happens to fall parallelly to the horizon or eye level. But what if she doesn't? What if she falls right straight towards you? She's going to fall somewhere, but where? So you're going to, later on I'll introduce the ellipse ruler, and I'll quickly just mention it. What's an ellipse ruler? An ellipse ruler is a ruler of ellipses, of how ellipses change according to distance. So at VP, just like imagine you're holding the water bottle at the eye level, just like when you're holding the water bottle, the ellipse is going to be straight because everything is straight at the eye level. So you'll have a straight line for ellipses at the eye level. And then they would get increasingly larger. Around here, you'll have a 60-degree ellipse, which we'll cover later on. Don't get boggled down by this. This is a lot in one lecture. We will cover it later, but just for fall on Delilah's, I will quickly say it'll fall somewhere on the ellipse. So one of the end points would touch the ellipse depending on how she falls. It could be here, could be here, could be here. That's how it's gonna look if the Delilah falls. And if she was to, this is something that I don't think Clap talks about, but I just thought of it. If she decides to twirl, think of a sphere, but let's not even get into that.
Why is it 60 degrees there? I'm confused.
That's just the way it works for some reason. That's how it
Is it like if it's on the eye level line, then it's 60?
it's a line on the eye level,
Mhm.
and then it gets to 60 and then goes into something very awkward because you see a circle under you, but you don't really see a complete
Right.
circle. So just we'll exhaust the topic of ellipses later on.
Okay.
But
Okay.
right now let's see what time it is.
The 60 degree is, as I
It's
remember,
5:26.
5:26.
Okay, I have to be at the bus stop at 47, so we'll
Oh,
have to finish up pretty soon.
yeah.
So shadows.